Welcome to the 2020 AIOH Virtual Symposium. Before we begin, a quick walkthrough of the event platform. Your home screen should have videos scrolling on the left and some interactive features on the right. Select Speakers tab to find out more information on speakers. Click on Individual Speaker to read their bio and session abstract. Click on Program tab to view session timetable. Select Sponsors tab to find out more information on event sponsors. Check out their videos, handouts, and freebies for attendees. There is also functionality for attendees to set up one-on-one virtual meetings with participating sponsors. Select Exhibit tab to find out more information on event exhibitors. Check out their handouts and freebies for attendees. During the symposium chat with other attendees, enter your full name and tick box to I accept terms of service and press join. You can ask presenters questions through the Ask tab below your chat screen anytime during the session. If you like a particular question asked, please tick thumbs up to upvote the question. If you have any technical difficulty, check on the Help Desk tab to get assistance. Now sit back and hope you enjoy the symposium.
Good afternoon and welcome everyone to the last day of the AIOH Virtual Symposium. I'm Linda Apthorpe and it is my pleasure to be the MC for today's sessions. To make the event more engaging, more exciting, remember to log into the chat throughout the session this afternoon and be part of that conversation. Remember to enter your full name and tick on the I accept to join the discussion. The session presenters today will be online throughout their session, so make sure you post any questions, any queries, and remember to check out the trivia tab for information for the trivia questions for today and participate in that daily quiz. You can also enter information for the previous day's quizzes. And remember, there's complimentary prizes to win for the best comments today and the best trivia question comments. So participate because there's been some great comments so far, so keep the commentary coming along. Check out the sponsors and the exhibit tabs as well because they've got some great information there and also for the latest products and services, and be sure to download their fact sheets and freebies. And some of them are also online for any immediate assistance, queries or guidance. So I'll keep joining you throughout the day. So for now, let the sessions begin.
I would say that you take every opportunity that this institute and this profession offers you. You never know where you'll end up.
Learn as much as you can from the current generation of occupational hygienists.
Know your limitations. Don't undertake work for which you're not qualified. If you don't do your own analytical work, make sure you use reputable laboratories. Obviously these days NATA accredited. Make sure you understand the method used and ensure that it's compatible with your sampling regime. In any dispute, I've learnt from bitter experience that emotion trumps reason every time. You can't reason with people's emotions of fear or anger or greed. So be realistic about what you can achieve by your occupational hygiene efforts.
Well, my message would be get involved with the profession and the Australian Institute of Occupational Hygienists and other hygiene associations as well. Make a positive difference to the lives of others And the most valuable piece of occupational hygiene equipment that I know of is a telephone, or nowadays it's email. Because there's always someone who knows more about the topic than you. Seek them out, they can help you.
Basically, three things. Firstly, take every opportunity to engage with others by joining an institute committee. Involve yourself in local activities that the institute may be running, like sundowners, these sorts of things. And thirdly, to promote the profession shamelessly. So as you interact with whether it's the general public, or whether it's a government official, or whether it's a supplier or a service provider, there's lots of groups out there that don't know a lot about occupational hygiene, so there's an opportunity for you to play a part in building that understanding.
Teach us old folks how to use social media platforms, and we'll teach you all about occupational hygiene.
My message to the next generation is welcome. Come on board, get involved. It's fun, it's exciting. We're a pretty cool bunch of people. There's a lot to learn. No day is the same. You will love it. It's really supportive. Welcome and good luck.
The Red OHMS Group is an Australian-owned and operated consultancy which specialises in health, safety and the environment. The business comprises of 4 divisions: OHMS Hygiene, OHMS Environment, OHMS Asbestos and OHMS Training. Since the Red OHMS Group was established in 2014, we have grown to become an industry leader with over 50 employees based out of our Perth, Kalgoorlie, Karratha, Darwin, Brisbane and Sydney offices.
OHMS Hygiene is focused on providing occupational solutions to businesses of all types and sizes. With 8 certified occupational hygienists, we partner with clients to lead, engage and mentor to achieve the legislative requirements and accompany clients for their journey to industry best practice. We specialise in air quality, risk management, radiation, noise and vibration, fit testing, ventilation assessments and more. At OHMS Environment, we customise our services to the needs of our clients, enabling them to achieve their operational and environmental objectives. Our team offers a high quality and reliable service using knowledge and experience from a range of industries across Australia. OHMS Environment specialise in management systems, monitoring and compliance, permitting and licensing and auditing. At OHMS Asbestos, we use a risk-based approach to provide a range of services to ensure our partners are equipped with both the knowledge and expertise to effectively manage the risk of exposure to asbestos. OHMS Training is an OHTA and BOHS approved training provider, offering specialist courses that promote safety and health and foster good working practices. We offer the BOHS Asbestos IP402 course and the BOHS iCert OH course.
At Red OHMS Group, our mission is to protect worker health by partnering with clients to help them understand and manage their risks.
Red OHMS Group looks forward to hearing from you soon.
Hello everyone, my name is Leon Stoudy and I'm a director within the Red OHMS Group. I'm honoured to be participating in this year's unique AIOH Symposium and supporting this event as a gold sponsor. I hope your symposium goes well. Now, I would like to introduce to you our invited speaker. Can I please welcome to the stage Francesco Torrici, and I hope I've got that right, who is Assistant Professor from the University of Torino. He will be speaking on a very topical subject at the moment, and his presentation is titled New Molecular Understanding of the Toxicity of Crystalline Silica. Ciao.
Good afternoon, and my name is Francesco Turci. I'm chemistry professor at the University of Torino, Italy. And I want to thank the organizer of this meeting, held online, and I'm flattered to be here this afternoon. I will to talk about some new findings that we had the opportunity to discover about the toxicity of crystalline silica. As many of you are aware of, respirable crystalline silica is a well-known toxic particle. When inhaled, crystalline silica particles with diameter lower than 5 microns can reach the lung, and that makes silica the leading cause of occupational disease, lung disease worldwide, still today. And after work of IARC and many other agencies worldwide, silica is now recognized as lung carcinogen. Of course, inhalation of silica is mainly occupational health issues, and there are historically related to inhalation of silica, like mining, construction, or sandblasting. However, there are emerging sectors that are bringing back silica fatalities, like artificial stone processing, where materials made up to more than 90% of crystalline silica are exploited and cut, usually maybe in small workshops sometimes. And there are studies, epidemiological studies from Spain or from Australia, that are showing that an incredible high number of silicotic patients or even progressive massive fibrosis have been recorded after, even when the exposure to silica has been stopped by years. Well, what happens when we inhale crystalline silica? Many of you know this very well. The silica respirable particles can reach the deepest part of your lungs, the alveoli, where they are put in contact with macrophages and cells that are dedicated to remove bacteria and also particles from our lungs. But what happens when macrophages interact with quartz particle? How can they manage the quartz particles? Well, this is the key of the inflammatory response pathway of crystalline silica. There have been a lot of studies in past, and now we know that when silica particles are internalized by macrophages, they are put in a cellular compartment that are called phagosome. Phagosome are interacting with lysosome, and here is where we can have the first detrimental event of the pathway of crystalline silica inflammatory response. The damage of this membrane may occur, initiate the activation of inflammasome, which is a cellular machinery that start inflammation. The fundamental question that we were trying to answer were, first, how does quartz disrupt this membrane? How does it interact with membrane of lysosome? And most of all, which silica properties initiate inflammation? And of course, if we can control these properties, could we be able to decrease or at least moderate quartz toxicity? Well, to do this, a few years ago, we created a model for quartz, a synthetic particle, a synthetic quartz crystal with a respirable size obtained without milling the sample. So it was we obtained perfect crystal from hydrothermal synthesis. And to understand the role of fracturing, that is always one of the key part of the quartz dust generation, we fractured this quartz, obtaining a very similar particle called the fractured synthetic quartz with the same size and morphology of the crystals, same surface area, but different surface properties. You can see here from high-resolution electron microscopy that the two crystals were different highly from the surface. But from the point of view of the atoms that are building silica, we can describe fracturing like this. So we have crystalline silica particles that when it's fractured, it creates very reactive species like radicals and ions. When those species react with water vapor in the environment, they create silanols. And silanols may still arrange in siloxanes bridges. So in the end, we were able to have ordered, highly hydroxylated surfaces from the pristine quartz and disorganized reactive surfaces from the milled quartz. We tested those samples for toxicity against macrophages, and we observed that the respirable as-grown crystals were non-toxic at all. But when they were fractured, they became as toxic as the positive control MinUCl5, which is a very well-known positive control in silica toxicology. Then we observed where the quartz was going inside the macrophages. And we observed that many particles were internalized both when the quartz was as grown, so inert, and then when it was fractured. So we built up a model where both as grown and fractured quartz were internalized. And then something differently happened here during the interaction with the phagolysosome. And to understand this, we needed to understand at what stage quartz was destabilizing cell membrane. So we created an experiment where we impaired the uptake of the macrophages. So the cells were not taking up quartz anymore. And we realized that all kind of quartz crystals were non-toxic. But when we raised the temperature again to 37 Celsius, then the quartz was again toxic as expected, and as grown quartz was still non-toxic. So after these experiments, we were able to improve our model, saying that at the lysosome membrane, we had two different reactions. When the membrane was interacting with unfractured as-grown quartz particles, the phagolysosome was non-perturbed. The membrane was intact, and we observed no cytotoxicity. On the other hand, when the fractured quartz was administered to cells, the phagolysosome was broken, and we observed a cytotoxicity and inflammatory response. So in 2 words, the cytotoxicity of quartz was elicited at the phagosome level and was due to some features that were induced by fracturing. So we needed to understand better what was going on the quartz surface during mechanical fracturing. And to do this, we needed to create a model of a membrane, a better model, more easy to understand. So we use red blood cells, which are a very well-known model for membrane, because the cells, these red blood cells, our red blood cells, are not internalizing objects. So differently from other cells, they don't take anything inside. Everything happens at the surface. They are very sensitive to lateral deformation. So even a very small amount of increase of the size of red blood cells brings the cells to break and to release hemoglobin. So this is the sort of a reactive scheme. So we can easily measure hemoglobin in the reaction system to detect how many red blood cells have been broken during the interaction with quartz. Okay, we started this system, and this is our very well-known as-grown quartz with flat surface, with high crystallinity that can be seen at high-resolution microscopy. So this graph here shows that compared to a positive control, the famous -5, the S-grown quartz was non-hemolytic at all, was non-breaking the cells. On the contrary, when we fractured this very same quartz, we observe the typical fracturing of quartz mineral, and also the high-resolution transmission microscopy, we could observe very new phases created on the surface. These new phases were the new point of contact between the cell and the quartz particles, and the very interesting, the hemolytic activity was again at the same level as the toxic quartz. So looking at the microscopic level, we observe that the typical conchoidal fractures could be observed during the quartz mechanical grinding. And also a layer of few nanometers was happening to be on the surface. Even if the bulk of the crystal was still crystalline and well ordered, this part was with a different structure, maybe not amorphous, but not crystalline anymore. So to understand this, we create a model of quartz, like a bulk piece of quartz with ab initio approach. We broke these and we make it react with water vapor. In this way, you create special moieties that are called silanols on top of your quartz surface that are oxygen bound to an hydrogen. These silanols, if they are to a proper distance one to each other, can interact one with each other. And this interaction change the frequency of oscillation of these silicon, of this hydrogen-oxygen bond. So this hydrogen-oxygen bond is very sensitive to the silanol environment. And from this table here, the intersilanol distance, you can see how this affects the vibration of this bridge, of this OH bond. Well, this is infrared spectroscopy. Even if you're not familiar with infrared spectroscopy, you can easily see that we have one part here and one big part here. So from experiments and calculation, we know that this part here in gray is related to the so-called strongly interacting silanols, the silanols that are all close together on the quartz surface. On the other part, you can find here this pink highlighted part that is related to the silanols that are quite far away, 4 from 6 Armstrong away. We call those silanols nearly free silanols because they were nearly interacting one each other. They were not free like this one, but they were nearly free. Okay, those silanols were very important for us because we observed that those silanols, the appearance of those silanols was responsible for the membranolytic effect. So when you take quartz, you grind quartz, you obtain an hemolytic particles. And at the same time, the amount of this nearly free silanol on the surface increased. We were able to analyze this in great details, starting also from a mineral quartz, not synthetic one, a natural quartz, very pure from Madagascar. So we heated the quartz and we increased the number of these nearly free silanols, and we observed that the hemolytic potential was increased. On the same, on the other way, when we heated again at 800 degrees, the number of nearly free silanol decreased, and also the membranolytic potential further decreased. So we had a quantitative relationship between the amount of nearly free silanols and the membranolytic activity. We didn't stop here. We observed that this amount of nearly free silanols was able to start pro-inflammatory and inflammatory activity, both in vitro and in vivo. You can see here pro-inflammatory activity in vitro and inflammatory cell recruitment, cytotoxicity, alveolar permeability, and micronuclear frequency in mouse model. Well, you can see that when the quantity of nearly free silanols increases, well, we have an increase of the activity of the particles. When it decreases, we have a decrease. So we have a quantitative relationship between the inflammation and the amount of nearly free silanols. So we started to create this model, a new paradigm for the toxicity of quartz, where the fractured crystalline silica particles were exposing different amount of nearly free silanols that were not present on the pristine quartz. And we observed that this nearly free silanol had a very specific intersilanol distance that was able to bind very selectively, very strongly, a negative head of a phospholipid chain. The phospholipid chain is the base structure for membranes. So this bond was very effective, very strong energy, and we think that that's why nearly free silanol are able to interact so strongly with membranes and disrupt cell membrane starting quartz inflammation. So to summarize what we have found out, we have 4 key points. First, that when quartz is fractured, the long-range order of silanols sitting on the surface is upset, and this generates a population of so-called nearly free silanols. These nearly free silanols can damage cellular membranes and initiate inflammatory reaction in vivo. Crystalline silica without nearly free silanol is non-toxic, and these challenge the paradigm whereby crystallinity is the critical part for silica toxicity. We have observed also that nearly free silanol with NFS, amorphous silica with NFS is inflammogenic. Finally, the discovery of this role opens perspective for a safer by design preparation of quartz dust and maybe even other particles. This is more or less all about I wanted to share with you this afternoon, and this is the group that I've been working with during the last I would say 5-7 years, very hardly. Cristina Pavan, who gets more the credit of all the experiments here. Riccardo Leinardi, former PhD in our laboratory. Professor Dominique Lison at the Université Catholique de Louvain, Bruxelles, who was PI for all the toxicological assessment, Dr. Anna Salvati at Groningen University, Bice Fubini, our mentor that started all these research on quartz, and particularly I want to spend just one word on Professor Gianmario Martra, who was one of my mentor and passed away suddenly on September 29th, when we were getting ready to celebrate this great scientific success and the publication on the proceeding of the Natural Academy of Science of this paper. So this research is dedicated to him, and thank you so much for listening, and I'm ready for taking your questions.
Ciao, Francesco. Thank you so much for that fantastic. Thank you so much for that presentation. I love the way that you can put something so complex into simple animations and diagrams. And we've had some fantastic comments coming through with appreciating your approach to dealing with this difficult, complex, for us as hygienists, topic, and appreciate your research into that. We've got some questions for you this afternoon, and the first one is how long do the RCS particles remain toxic for after cutting? Can you give us some information on that?
Yes. This is a very, very important question, Linda, and I'm happy that someone from the audience is wondering about that, because this is one of the key part of the new investigation that is starting now, and we are working on that part right away. Because as you have seen, since the molecular dynamics of this silanol group can be very can change during time. So we are expecting the kinetics of formation or degradation of those working of these silanols may be different, maybe changing the surface state with time, and we are very anxious to understand if quartz remains toxic for ages, or maybe something changes in short times. Right now, we are investigating this part with a 2 years long study. And at the same time, we are also investigating the very first second of creation of these surfaces when you break the quartz crystal. And we are really trying to understand what happens at the surface at the very first seconds.
I think that's important. That aging component is one of the elements that helps us to understand the toxicity of it, particularly from a hygiene and a control perspective. There's another question that's kind of connected to that. If water deactivates the reactive surface, does it imply that quartz is only toxic for a short period of time after inhalation? So it's kind of connected to what you were just saying.
Well, it doesn't. It's not like that. I mean, we have natural milled quartz that are keeping their active silanols for years. They've been milled, we don't even know when, 2-3 years ago, and they are still having this surface. So what we are trying to understand now is that if milling or cutting in different ways can create different surfaces that are stable, and then these can be very important to defining better methodologies, maybe to handling these materials.
Yeah, that makes sense.
I don't know if I answered the question.
You're doing well. We've got some other ones. We hope to get through as many as we can in our few minutes. The next one is in Australia at the Queensland Prince Charles Hospital. They've actually discovered a new breakthrough. Do you know about this, where they actually want to flush the lungs with salt water to help silicotic patients. What's your comments and any other discussion about that you'd like to add?
Oh, well, generally my comment at this point is I'm just a chemist. So when things get too into the medical field, I stop talking usually.
Leave it to the medical guys.
Yeah, and I do the analysis. No, really, I understand that it's a important breakthrough because we have silicoting patient, and the number, as we all know, are growing in some sectors. So it's very important to be very proactive, and of course, the medical part is doing their job, and hopefully, creating better treatments is always very, very good and important. On the same side, we are working on the preventive part of the research. So maybe trying to have a less toxic quartz one hand, or understanding why it is so toxic sometimes. That could also be an aspect.
Yeah. Okay, well, very well answered. I just got one more question I think we've got time for. I'm going to squeeze it in. When you fracture the homegrown quartz, do you obtain comparable particle size distribution to the MinUSil 5?
Yes, MinUSil 5 was used in our experiments, in all our experiments, as the positive control, and we were always matching the surface area and the particle distribution size with MinUSil 5.
Yeah. Okay. There you go. I hope that was answered your question. Thank you so much, Francesco. Grazie very much. Grazie mille. And we're going to leave you this afternoon and wish you well for the rest of your day. It's beginning of the day. It's around 5 a.m. in the morning in Italy where you are. So thank you so much for helping us with our symposium and contributing to our scientific content. Your information is fantastic. Thank you.
It was a pleasure, and thank you for having me here, Linda. Bye.
Bye-bye. Okay, that was fantastic from Francesco. Our next session is about biosolubility of engineered stone in simulated lung fluids. And it's presented by Preeti Maharajan, who's a student at the University of Adelaide. Remember to use the chat feature to ask the presenter questions throughout the session, and I'll see you after this session.
Thank you very much for being here today. I am Preeti Maharajan. I am final year Master of Public Health student at the University of Adelaide, and I am here today to talk about my research project on elemental biosolubility of engineered stone in simulated lung fluids. What I hope to show through my presentation today is metal ion may have potential implications on the disease development of engineered stone associated lung disease, and there is a need to further improve understandings of these ES dusts. We are all aware about the silicosis cases have been rising, driven by the increasing trend of the use of the engineered stones. The processing activities of engineered stones, such as cutting and grinding using powerful tools, produce inhalable and the respirable dust that contain free or particle-bound metal ions. These dust, upon reaching to the lungs, induces the macrophage activation. The macrophage then engulf these dust particles by a process called phagocytosis. Phagocytosis either result in clearing these dust particles and metal ions, or result in cell death that will release cell particles and the dust particles, which further attracts new macrophages and neutrophils. This continuous cycle causes the persistent inflammation, which evoke the disease such as autoimmune disease, lung cancer, and the exerted silicosis. Literature reviews suggest that these metal ions induces the overproduction of the reactive oxygen species in the cell, resulting in oxidative stress, which eventually result in apoptosis, which is a programmed cell death. The aim of my research is to understand the biosolubility of metal ions in engineered stone dust exposed to artificial lysosomal fluid. In this presentation, I am not talking about the physicochemical properties, mineralogical content, or the organic content of the engineered stone dust. I'm only talking about the biosolubility of the metal ions in ES dusts. The primary research question for my research project is there metal ions release in artificial lysosomal fluid as a result of contact with engineered stone dusts? Given that there are various types of engineered stones available in the market, we were also interested to understand, is there a difference with different stone type or a difference in trend with time in metal ions release in artificial lysosomal fluids. The artificial lysosomal fluid with pH 4.5 simulates the in vivo physiological condition of acidic intracellular environment of lung cells. We used artificial lysosomal fluid mainly for two reasons. The first reason is ALF has higher extraction of metal ions, and secondly, ALF has relative stability of bioaccessibility. The research approach can be broadly classified into 4 steps. The first step is stone sample collection, followed by the engineered stone dust generation, biosolubility assay, and elemental analysis. Talking about the methodology in detail, the engineered stones was first cut using wet saw diamond blade and cast into gravel-sized engineered stones using a jaw crusher in a specialized mineral processing facility at School of Earth Science in University of Adelaide. Then the gravel-sized engineered stones was comminuted using tungsten carbide ring mill, generating the respirable and the inhalable dust. These generated respirable and inhalable dust was mixed with artificial lysosomal fluid, and the mixture was incubated at 37 degrees Celsius and 80 speed. The simulated ALF was extracted at specific time periods for elemental analysis. Out of 18 different engineered stone types collected from 5 different suppliers, for this research project, 4 different engineered stone types were assessed in triplicates, and the concentration of released metal ions were measured at different time points, 24 hours, week 1 and week 2, and 12 different types of metal ions were assessed at each time point. These are some of the pictures that shows us in action at lab. Oops. Among 4 different engineered stone types assessed in this project, 2 of them were dark colored, whereas 2 engineered stone types, ES1 and ES4, were light colored. And among 4 stone types used, 3 of them had high organic content and 1 had low organic content. The linear mixed effect models indicated that the change in iron, aluminum, and titanium concentrations differed between different stone types. In the graph here, we can see that the mean iron concentration is higher among the dark-colored stones ES2 and ES3 compared to the light-colored stones ES1 and ES4, and the size of the difference increased significantly from the 24 hours to week 1 or 168 hours. For titanium, opposite was observed. The titanium mean concentration was higher among the light colored stones ES1 and ES4 compared to the dark colored stones ES2 and ES3, though the difference is not as pronounced as in iron. Plant contrast was used to estimate mean difference between different colored stones and stones with different organic content. The estimated mean concentrations of iron and aluminium were significantly higher in dark colored stones compared to light colored stones at both time points 24 and 168 hours. Whereas the estimated mean concentration for titanium was significantly higher in light-colored stones compared to the dark-colored stone at both time points. Similarly, for the organic content as well, the estimated mean concentrations of iron and aluminium were significantly higher in stone types with low organic content compared to the high organic content at both 24 hours and 168 hours. And for titanium, the estimated mean concentration was higher in light colored stones compared to the dark colored stones at both time points. For two stone types, ES1 and ES3, the mean metal concentration was estimated or measured for 3 time points, 24 hours, week 1 and week 2, and there was an evidence of interaction between stone type and time points for iron, manganese and aluminum. We can see in the graph here that the mean iron concentration is higher among the ES3, which is a dark colored stone, and there is a significant increasing trend from 24 hours to week 2, whereas it is a kind of a constant for ES1. Similarly, for manganese, the mean manganese concentration is higher in the dark colored stones ES3 compared to the light colored stone ES1. And there is a slight increase in manganese concentration from 24 hours to week 2 time point, whereas it is constant for stone type ES1. To conclude, the engineered stone dust, upon interaction with artificial lysosomal fluid, released free or particle-bound metal ions, and the overall concentration of metal ions and the rate of change in concentration over time differed between various stone types, with varieties of stone types available in the market and the preliminary data suggesting the variability of metal ions concentrations according to the stone types and time points. There is a need of further toxicological studies of these engineered stone dust compositions. Last but not the least, I would like to thank my supervisor, Professor Dino Pisanillo, and all the people and the organizations mentioned in the slides here. Thank you very much for listening to me.
Thank you very much, Preeti. I think you're exactly right. There is lots more work to be done on engineered stone, and I love the way you've been answering the comments in the chat, so keep that up. Thank you very much. Our next session is about occupational respiratory hazards in the hemp and emerging medical or medicinal cannabis industries, and it's presented by Dr. Maggie Davidson, who is a lecturer and researcher at Edith Cowan University. Remember to use the chat feature to ask her questions throughout the session. Over to you, Maggie.
Hi everyone, and welcome to our virtual conference. It's Maggie here giving you another update on medicinal cannabis and where we've gone since the last conference. Thanks to Tim, who's engineering all this behind the scenes, and thanks to my co-researchers. This is a collaboration from Edith Cowan University, Western Sydney, and the Australian Medicinal Cannabis Research and Education Collaboration. I'll get right into it because we've got a lot to cover very, very quickly, and I only have 10 minutes. So cannabis, it's a crop that got mothballed for most of the 19th century. But prior to this, it was a very important crop. It was considered one for tactical advantage. So whoever had the hemp had the rope, had the sails, and had that defense capability. So the first seeds were donated by Sir Joseph Banks, and we also had a lot lot of hemp medicines, but I'm going to have to quickly skip through this because my first minute's nearly up already. So what we see is some big changes from about 2016 onwards, where you would have heard me first coming in and talking about this. We saw medicinal cannabis reclassified from Schedule 9 to Schedule 8. And with that, we had the opening up of the commercial markets here. Refer to TGA for more information if this is an area of interest. But the problem is, because it was illegal for most of the 20th century, there's a lot we don't know about the specific hazards associated with the plant itself, as well as the conditions under which we cultivate it and we actually prepare the medicinal cannabis therapeutic goods, or how we actually prepare the industrial hemp products, manufacture those, and how they're used in industry. So we've got a ways to go to characterizing the specific hazards from cultivation and manufacturing. So just a quick overview, the two difference, it's the same plant, it's all cannabis sativa. For hemp, we actually have, it has a lower THC content, which varies depending on state to state, and territories, to check your legislation to see what the definition of hemp is, because it can change right up to 1%. We tend to avoid the word marijuana for medicinal cannabis because marijuana carries a lot of connotations. In the industry, we're trying to move away from the stigmatization that the plant had over majority of the 20th century. I told about the big change in 2016. 2017, we saw food standards change to permit hemp seed as a food crop. And just this year, we had the wonderful change where we saw that cannabidiol, one of the over hundreds of phytocannabinoids in the plant, has now been made Schedule 3, which is available over the counter. So we're growing, and from the industrial hemp perspective, Tasmania, the last territory has permitted its first industrial hemp crop. So big times ahead, which is great to see. It's an amazingly versatile plant, which can pretty much be grown Australia-wide. It's got requires less water use, and it's got so many different products that can be created about it, can be used from it. So just a little bit of the differences between the two products. So medicinal cannabis is predominantly an indoor crop. We're trying to protect it. We're trying to keep it as pure as possible and because this is a therapeutic good that's going out to patients. Industrial hemp's basically a broadacre crop. So there's a lot more hands-on in medicinal cannabis production, whereas the industrial hemp, it's going to be more machine production. So you've got your classic agricultural hazards associated with the industrial hemp, noise, dust, vibration, and evidence coming from the field that it's really playing havoc with their industrial machinery, blockages and spot fires and the hazards that come with that. For industrial hemp, the concerns really when we're coming to the product is during the post-harvest, when we're starting to produce the hemp fibers. As Melinda presented in one of her previous conferences, we saw a lot of dust is associated with this, and also depending on how the mill is set up, it can be quite open. There's going to be potential for a lot of biological bioaerosol exposures. Hempcrete is one of the new building materials. We've got, I think it's over 200 plus hempcrete houses in Australia now. It's a mixture of hemp fibers, lime-based binders, and other ingredients, including Portland cement. And when I first saw it being produced, people were doing a structure and ramming the product down between the structures, generating dust. But we're seeing a movement away from this into actual hemp panels and hemp bricks, which could reduce the potential dust exposure associated with this kind of building method. Flipping over to the medicinal cannabis side, this is where a lot of the interesting research is coming out right now. And there was a really good issue of the Annals on cannabis production, and I'd like to draw your attention there for more information, what I'm going to quickly cover in the last 4 minutes of this presentation. So hot, humid environment, perfect for mold growth. Mold growth, not good for therapeutic goods, so let's use some aggressive cleaning strategies, lots of hazardous chemicals, or in some cases they're using UVC lights, and the lovely hazards that come across with those to keep these little guys in check. So got to be careful of the workers. What's their UVC exposure? Sorry, not UVC, that's the light. So they use UVC, metal halide, sodium. What's the potential UV exposure for workers under those grow lamps? The biological hazards, of course, you all know I love my endotoxins and my bioaerosols, so the implications that those pose to workers. We have physical hazards, heat stress. They're also using air purifiers in some cases, ozone generation, so let's throw that into the mixture too. The mechanical ventilation, carbon dioxide gas is used as a growth promoter. So that's another hazard that you find. One of the biggest areas that was focused, this was Colorado and NIOSH looked at, is the actual biomechanical injuries. It's quite tricky to get in and around the plants, maintaining them. And also when you're trimming and preparing the inflorescences, there's a lot of potential for hand strains and injuries. And also, last but not least, the stigmatization of working in the industry. And there's some interesting papers where people perceptions, not just for what you do for a living, but also the stress of working in a very highly regulated industry. This is stressful. They're always worried that their product's going to be okay, that they're not going to lose their license. And this can be an intense environment for people to work in. In the US, this is where we're seeing most of the information coming through and most of the research. 3M's partnered up with the medicinal guide, OHS guide to growing, not medicinal, to recreational cannabis, and they've been doing a lot of safety talks, and this has been great for providing guidance to the industry, and they want this training. They've asked for it, so it's being very well received on how to protect your workers. The endotoxins are there as we would expect, up around mostly during things like when they're actually crushing product and producing, say, the joints. This is a recreational industry that this data is coming out of. You're going to be mixing with the plant fiber, so you're going to generate dust. You're going to have your endotoxins. We have a number of different fungi identified. You recognize these guys for hypersensitivity reactions, as well as the bacteria. That's my 2-minute mark. Actinomycetes. So these have been linked with hypersensitive pneumonitis. We've got the VOCs. Remember, these plants are highly aromatic, so we're going to have a lot of VOCs, and also considering for secondary pollutants from these VOCs as they undergo oxidation. We see, remembering those of you who popcorn lung, diacetyl's back again. This is highest, the data suggests, during the decarboxylation period. Decarboxylation, for those of you who knew, is the process by which the THC, that psychoactive component, is transformed from its acidified state to its bioavailable state. And this is an essential part of the preparation. But when you're heating and warming a plant to do this, you're also promoting acceleration of the vaporization of these volatile organics. Not so much in Australia, we hope, but high residual pesticides, including some very, very nasty ones, have been reported. This is from a study that comes out of Oregon, looking at the quality. I've got 1 minute to go. And reports of work-related asthma, allergic symptoms, and the biomechanical issues, which is problematic. So far, NIOSH have done 4 health hazard evaluations of commercial cannabis farms, and again, these were published in that Annals article. So trimming, grinding, decarbox, and extraction, these are the areas where you're going to see the highest exposure. So again, just keeping an eye on those plants, release terpenes and phytocannabinoids, because this is where we don't know. This is the unknown quantity in a growing industry here, Australia and worldwide. The Washington State study is the first health hazard evaluation that are comprehensive to date, and my time's up, but I'll wrap this very quickly. They had some interesting suggesting work-aggravated allergy symptoms, but the study was hinted that 97% of the employees actually were recreational cannabis users. So you can't draw conclusive evidence when you have this contraindication, really. But again, a very interesting study to read up, and they also, as part of this study, looked at the terpenes and the phytocannabinoids. So I'd like to draw your attention to Australia. Situation hopefully I'll be on the field next year. I'm getting back in to work with our research partners, looking at what the hazards are and helping them to characterise and control here in Australia. The Guide to Worker Health and Safety, this is still the primary information that we have. It's been adopted by a number of states in the US. And again, the Annals article I'd like to draw your attention back to for more information. So keep the levels as low as reasonably practical. Again, there's still a lot we don't know about the plant and the long-term chronic exposures and implications. The VOCs, the post-harvest, is where we're focusing for the moment, and we definitely need more industry guidance. So that's where I'd like to leave it today, and say a big thank you to my research partners, to AIOH for giving the opportunity to give you this update, and I hope to see you in 2021 with my notes from the field to add to what's happening in the American space. Thanks again.
Thanks so much, Maggie. I love the way you keep on putting research out in this area. It's obviously generating a lot of interest for you as a researcher, and it also generated a stack load of comments on the chat. So keep it up, keep the comments coming, and we're going to move on to our next session for this afternoon, which is indoor environment quality in a dental facility, assessment of indoor air quality, lighting and noise. And it's presented by Hannah Menzies, who is a student at ECU University in Western Australia. And keep that chat coming. I'll hand it over to you, Hannah.
Hi, and welcome to my presentation on the assessment of indoor environment quality in a dental facility. My name's Hannah Menzies, and my project supervisor for this project was Associate Professor Sue Reid. This study presents the findings of exposure monitoring that was undertaken at a dental facility to determine the exposures of workers to components of indoor environment quality. So what is indoor environment quality, or IEQ? It's a term that refers to the quality of a building's environment in relation to the health and well-being of the building's occupants. The health and financial benefits of a healthy indoor environment have been well documented and linked to occupant productivity and well-being. It is currently estimated that people in Western society spend, on average, 90% of their time indoors, so this is a growing issue. The components of indoor environment quality that have been identified include indoor air quality, lighting, and noise. Exposures to these components outside recommended guidelines can lead to detrimental health effects for workers and other building occupants, including noise-induced hearing loss, respiratory irritation from airborne contaminants, as well as stress and a decrease in worker productivity. In a healthcare setting, such as a dental clinic, there are various processes that can affect indoor environment quality. There are also often competing priorities between patient comfort and employee exposures, as well as considerations to be made for infection control requirements. Dental procedures, including drilling and grinding, may generate aerosols, and the manufacture of dental appliances and sterilisation, as well as cleaning procedures, may produce exposures to total volatile organic compounds. Dental equipment can also generate a large amount of noise, and infection prevention requirements can also influence building design or the possibilities of acoustic controls. The aim of this project was to establish the levels of indoor environment quality parameters in a dental facility. More specifically, it aimed to determine if exposures of staff working in the facility were below exposure standards or recommended exposure guidelines, and to make recommendations for controls where required to ensure workers were not exposed to the risk of detrimental health effects. To meet this aim, the project had the following objectives: to determine what was currently known in the literature about indoor environment quality exposures in a dental setting, to measure indoor air contaminants, noise and lighting, and to compare these exposures to exposure standards or recommended maximum exposures, and to recommend controls where monitoring results indicated unacceptable exposures. The selected dental facility was located in Darwin in the Northern Territory of Australia. The facility provides oral health services, and staff include dentists, dental assistants, sterilisation techniques, dental laboratory staff and administration staff. These staff work predominantly 8-hour shifts, Monday to Friday. Monitoring for indoor air quality, noise and lighting was undertaken in 3 work areas, including the dental surgery, the sterilisation room and the dental laboratory. The climate in Darwin is tropical, with a wet and dry season, and measurements were taken during the dry season when outdoor conditions were warm and dry. Indoor air quality measurements were taken using a Yes Air D air quality monitor. Exposures were then compared to maximum recommended exposure levels from the Australian Building Code Board's Indoor Air Quality Handbook. Personal noise dosimeters were then used to measure noise dose over a shift, and these results were compared to the workplace exposure standard set by Safe Work Australia. Activity-specific measurements were also taken using a sound level meter at ear height, and a frequency analysis was undertaken to determine the characteristics of this sound. A lighting survey was then undertaken according to the Australian Standard for Workplace Lighting. These measurements were compared to the minimum recommended illuminances listed in this standard. The results for indoor air quality monitoring revealed measurements of total volatile organic compounds, or TVOCs, that exceeded recommended maximum guidelines recommended by the ABCB. This is consistent with previous research studies that also showed high TVOC levels in a dental clinic. Excessive exposures to TVOCs can lead to detrimental effects on human health, including headaches, dizziness, and eye and respiratory irritation. The measured exposures to carbon dioxide were below the recommended maximum limit, but very close to this limit for the sterilisation area. Noise exposures measured using the personal noise dosimeters were between 70 and 77 decibels with an A weighting over 8 hours, which are all below the workplace exposure standard set by Safe Work Australia of 85. This exposure standard is set at a level to prevent noise-induced hearing loss. However, the Safe Work Code of Practice for managing workplace noise also recommends keeping noise below 70 decibels with an A weighting if the work demands attentiveness, such as work undertaken in a dental facility, including dental treatment, consultations, and dental laboratory tasks. Analysis of the sound frequencies and tonality for the activity-specific noise measurements was undertaken by looking at the data for each noise measurement point and looking for a variation of greater than 5 decibels each way for each frequency. Several of these were identified as evidenced by the graph. Tonality of sound at high frequencies has been linked to an increase in annoyance response. Measured illuminances in many work areas were more than double the recommended level in the Australian standard, which could lead to the development of glare for workers. There are also a smaller number of measurements below the recommended illuminance, which could lead to unsafe conditions and eye strain where visual acuity is required to complete tasks. Lighting requirements in medical facilities often have competing priorities, with the requirement to consider patient comfort alongside the needs of staff to ensure they have enough visual acuity to complete treatment. Task-specific lighting is often used for this reason when completing treatment and work in the dental lab. This exploratory study identified several exposures of workers to indoor environment quality parameters that were outside the recommended guidelines and therefore increased the risk of potential detrimental health effects occurring. Based on the outcomes of this study, it was recommended that further measurements be undertaken in the dental facility to determine the type and source of TVOCs in all work areas. It was also recommended that a ventilation assessment be undertaken to ensure that the current ventilation system was working correctly and that the flow rates are operating according to system design. It was also recommended that noise controls be implemented at the dental facility due to the variance in frequencies of the noise emitted by dental equipment. Control of noise should be further investigated to ensure sound levels can be decreased in accordance with infection control requirements. Finally, it was recommended that the lighting that's currently in place be reviewed to reduce the potential for the development of glare. There have been minimal previous research that looks at the combination exposures to all indoor environment quality parameters in a dental facility. Further research is required to determine whether any of the reported exposures by dental workers to these indoor environment quality parameters correspond with any increase in symptoms, detrimental health effects, and perceived satisfaction and reported stress levels. Thank you very much.
Thanks so much, Hannah. I think we'll all be thinking a bit differently next time we visit the dentist. A complicated study, and I'm sure 10 minutes was not nearly enough to describe everything that you completed in that. So thank you very much. Our next session is about the development of a thermal risk assessment tool for courier drivers, which is presented by Claire Di Coletto, who's an occupational hygienist at Monitor Consulting Services in Queensland. Remember to keep that chat going. There's some great comments coming along, and thanks, Hannah, for being online for that. And also, Claire, I know you're there to answer comments. Over to you, Claire.
Hello, and thank you for that introduction. So good afternoon. My presentation today is on my master's research project at Edith Cowan. I would like to take this opportunity to say thank you to Alex Todorovic and AES for the scholarship that I received, which has allowed me to complete my research. I also like to thank Jacques Oostenhuizen, who was my supervisor, and Sue Reed, who helped get the idea off the ground at the very start. My presentation is about the development of a thermal risk assessment tool for courier drivers. With the rise of online shopping into homes and businesses, especially with the recent pandemic, more and more people are using courier drivers for deliveries. Services such as the United Parcel Service, or UPS as it's commonly known, are now a common sight in the US, and it has been highlighted that vehicles are not always air-conditioned. One such report was from a representative of UPS who stated, "Our delivery vehicles make frequent stops and the entry doors and rear doors are frequently opened and closed throughout the day, making air conditioning ineffective. This could have contributed for several hospitalizations and one fatality." The first aim of this project was to determine the thermal stress risk associated with the operation of vehicles to the drivers. Using this information, the second aim was to develop a basic thermal risk assessment tailored to work completed by the drivers. For my project, I looked at two main components that could impact on the internal conditions of the vehicles: color and shade. In the color assessment, using 3 Quest Temp heat stress monitors, a unit was placed in one white and one dark blue sedan, with one between them to compare against the ambient conditions. The vehicles were fully closed, with the monitors set up to data log every 5 minutes. A similar approach was used for a white courier van. This was to compare between letting in the sun and shade. Using the same van, airflow testing was completed with both of the windows open whilst driving at various speeds. This was completed to determine how much air moves across the driver. The next part of my project was using a predicted heat stream program to determine the impact of the vehicle conditions on the body with different workloads. By using different workloads, it was possible to simulate the different types of manual work that drivers could potentially undertake during their normal day. 3 main parameters were selected based upon the needs of the PHS program. These were dry bulb for air temperature, globe for radiant heat, and humidity. Looking at the dry bulb, the comparison between the blue vehicle, so the red line, and the white vehicle, the green line, shows that whilst they both increase at steady rates, the blue vehicle reaches a higher temperature than the white. This was also the case when the globe temperatures were compared. Both rose at similar rates, with the blue vehicle again being the higher result. When you compare the humidity readings, both vehicles' interiors drop well below that of the ambient results. After completing some statistics on the results, it was found that there was a significant difference between the blue and white vehicles, indicating that this is an important detail when regarding potential thermal stress exposure in vehicles. Based upon the fact that some vans do not have air conditioning, it was important to determine the impact of airflow on the drivers, as this would be their key cooling control. It was found that there can be various factors that impact the way that air moves into the cab based upon the wind itself. Air movements such as crosswinds can greatly increase the amount of air through the cab, which would increase the amount of cooling that drivers experience. From the airflow testing, it was confirmed that the amount of air movement across the driver was high at the higher speeds. These measurements were taken between the driver and the steering wheel over an average of 6 measurements using a hot wire anemometer. The measurements for both windows open when stationary and at 100 km per hour were used for the assessment for the predicted heat strain. The PHS program used was developed by FAME Lab from the University of Thessaly in Greece. It was used for the completion of the analysis of predicted body core temperature. For my project, I used the parameters of an 80-kilo person at 180 centimeters tall and fully acclimatized. During the analysis of the work, it was found that when driving, the overall effect on heat strain was significantly impacted by the airflow, even with low metabolic loads. However, courier drivers do not always drive at high speeds, so the key control is not always available. In this first scenario, the dry bulb and globe temperatures were set to 50 degrees Celsius, with the workload set to 175 watts per meter squared, to simulate heavy lifting that can be experienced by drivers with stationary airflows. Based upon this information, drivers would exceed the recommended 38 degrees centigrade body core temperature within 32 minutes. This was then tested by reducing the workload and the time for completing the equivalent of smaller packages still exceeded within the hour. However, when the airflow was increased to that of high airflow at 100 km per hour, even with the high physical workload, the driver would not exceed the recommended 38 degrees. For drivers, a basic thermal risk assessment could help with determining their potential risk for the day. It was found, however, that the standard assessment was not suitable as the variations for potential exposure were different. The normal assessment is more tailored for construction and resources industries with references to situations such as confined spaces. This modified assessment was developed and now takes into account the two main areas, loading of vehicles and the actual delivery. The main changes were the inclusion of lifting, using either aids or teams, package size, walking distance, number of deliveries, and the vehicle cab conditions themselves. Most of these impact on the metabolic load of the driver, which can increase their risk. Two are similar to the original assessment, with exposure periods having a shorter exposure time and climbing up and down of stairs. Although we have shown that colour does impact, it was not included in this risk assessment as some companies may only have a single colour for the vehicles being used. Imperial units were also used in this assessment as the source information used for this project was based on the issues in the United States. So, based on all of this information, what did I find? I found that colour does have a significant impact on internal conditions of vehicles. This was also supported in the literature by multiple studies. Also, that shade has a profound impact upon the vehicle and that conditions are more stable when under cover. When these two conditions are combined with increased airflow, I found that airflow can play a significant part in reducing the exposure of heat stress upon drivers. Through the use of the predicted heat strain modelling, it was determined that factors such as the amount of physical work completed by drivers as well as their acclimatization status also plays a role. With heavier workloads, more heat is generated by the body and thus requires higher airflows or cooler temperatures to reduce the core temperature. It is important to note that courier drivers' tasks often result in a stop-start operation which can adversely impact on the airflow. Using all of this information based on what has already been developed for risk assessment strategies for heat stress, the basic thermal risk assessment in its current form was not found to be suitable for courier drivers. This is due to their unique work style and high mobility. Through adjusting the assessment, we are able to assess their potential risk for heat throughout their day based upon their work and their changing conditions. Thank you very much.
Thanks so much, Claire. You delivered on your research very well, and there were some great comments coming through. Keep answering those. Thank you very much. And it seems kind of obvious, doesn't it, when colour plays an important part in the internal area of a cabin of a vehicle. Thanks very much. Our next presentation is about the occupational heat stress, continuing our theme of heat at the moment amongst outdoor workers in Africa and Australia. And it's presented by Jacques Oosterhuizen, who's a Professor of Occupational and Environmental Health from ECU University in Western Australia. The session is sponsored by Edith Cowan University, and also with the other exhibitors and sponsors. Make sure you go to those pages. There's some free downloads and some great information available on those exhibitors and sponsor pages. And keep up the chat. See you after this session.
Hi, I'm Jacques Oosterhuizen, Professor of Occupational and Environmental Health and one of the certified occupational hygienists here at ECU. Our team teaches and undertakes research in the field of occupational hygiene. Occupational hygienists work across a range of industries, including mining, oil and gas, and manufacturing. Our aim is to maintain worker health through recognizing and controlling biological, physical, and chemical hazards in the workplace. ECU offers a graduate certificate, graduate diploma, and a Masters of Occupational Hygiene and Toxicology. Our Master's course is professionally accredited, both nationally and internationally. ECU's courses in Occupational Hygiene and Toxicology were developed in consultation with industry and are taught by experienced practitioners. Our Master's course includes practical workshops and site visits to industry partners. You will get to see how the specialist knowledge that is learned during the course is put into practice in the workplace. You will also get plenty of hands-on experience in our world-class teaching facilities. We have invested heavily to ensure that our equipment mirrors what you will use on the job. Our courses are delivered mostly online. They're facilitated by online learning platforms so you can build relationships and your professional network. So, if you're thinking about upskilling and furthering your career in occupational and environmental health, you should come and study at ECU.
Thank you, everyone. So today I'm going to talk about occupational heat stress and some of the research that we've done amongst cohorts of workers, both in Africa as well as in Australia. So I guess there's not a lot of us that still don't believe in climate change. I think most people accept that it is real and that it's not just heat, but it's just basically a combination of things, probably better described as a shift in weather patterns. But amongst that, we do have obviously an increase in the sort of frequency and severity of heat waves. And so, of course, there are a lot of people that work outdoors and they will be subjected to all sorts of heat stress. So the aim of this review was to look at strategies that people use to mitigate the impacts of heat stress, particularly those that work outdoors. And over the last 5 years, we've had quite a few students that have done research on this topic, both in Africa as well as in Australia. And so there are a lot of lessons that we can learn by looking at this from a multidisciplinary and a multinational perspective. So just like to start off by acknowledging the PhD students. So we have got Victor Nunfam, who did his research on mining in Ghana. Kwasi Fimprong, also from Ghana, but he looked specifically at farm workers. Big Boy looked at street vendors in Zimbabwe. And many of you might remember Joseph Matei, who was one of our PhD students that moved on to do a postdoc and also was a member of AIOH a while back. And he's subsequently gone back to Canada. Then Francis Bandy and Tamara Doset both did their Master of Occupational Hygiene and Toxicology. And currently Edmore Masaka, one of our new staff members here actually, is doing research on pathogens that grow in plumbing systems. So there's just some of the papers that have been published. You'll see there are quite a few out of Africa, and then we also have the Australian research. So if anybody needs any further information, that's all published research that is available. So kicking off with Ghana, basically we're looking at mine workers in Ghana, and it's very interesting there that we have two absolutely distinct types of mining. We obviously have the formal and the informal. Now, the problem with the informal is that it's also illegal, largely. So that's, of course, an issue. So the multinational organizations employ around 11,500 workers. That was in 2017, whereas in the informal sector, it's estimated there could be 1 million people working as this person is in this photo in an informal environment. Of course, in Ghana also, we have hot and humid conditions during the summer, which would make heat stress an issue. The informal activities are characterized by heavy physical work in direct sun, and obviously there's an absolute lack of OHS systems and protections for the workers. You'll also note that the water this person is sitting in amongst would not be potable. And a lot of them also have inadequate housing and no means to really cool down, particularly if the nights are warm. And of course, they don't wear any personal protective equipment. The formal sector is very different and probably very similar to what we would experience in Australia. The big difference, I guess, is that most of their mining would be underground. So the heat associated with underground mining is obviously not necessarily got the sun as an impact, but there's a lot of plant and equipment underground that also contributes to the heat load. But of course, they have proper health and safety systems, employee protections, income security. They do work longer shifts, but they obviously have all the necessary PPE, which in some cases can actually contribute to thermal heat load. So just returning back to those informal workers, the ways in which they cope and have adapted to heat while they work is to take regular breaks away from the hot conditions. So if there's shade, they will try to sort of take a midday siesta. They obviously also work less hours and might start earlier in the morning. And they do report using electric fans at night or when they're at home, if available. Now, they face significant barriers in terms of coping with heat stress. There is a lack of knowledge and education about heat stress and coping behaviors. They lack access to potable water, so there's a lot of problems with dehydration. They don't have very good OHS knowledge to start off with, particularly as it pertains to heat stress. There's a lack of management and commitment to OHS. So many of them will work for somebody, but it's a very informal arrangement. So they have no real protections. There's a lack of technology. So the work is very manual and they work under hot conditions outdoors. So there are sociocultural and economic barriers that obviously get in the way. And they have to rely on the national health system for their health care, and that is not also necessarily the best way to go. And also they're pretty poor. Most of them don't earn a lot, and they can't afford adequate housing and don't have access to electricity. And then I guess just by the mere fact that their activities are illegal, and cause significant harm to the environment. It's not something that is necessarily going to be encouraged by the government in terms of providing them with any formal sort of protections. Of course, by contrast, the formal sector, which I guess many of the audience might actually be familiar with, they have what you would expect on an Australian mine site. So the workers have regular hydration, they wear loose-fitting clothing, they use mechanical equipment, which reduces the need to do hard physical labor. They obviously have job training programs and decent OHS systems. They use job rotation and also have PPE when they do work outdoors to protect them from radiation, sunglasses, sunscreen, wide-brimmed hats, and of course they have better health protection and social protection measures, and they earn more. They have a steady wage and often will have the ability to cool down at night because they have electricity as well. So their barriers are apparently poor compliance and implementation of heat stress guidelines, policies and programs, inadequate financial resources to support some of the engineering controls for heat stress, and they do also complain about a lack of regular training in terms of heat stress and health and safety issues, and they complain about a lack of a management commitment to health and safety measures. So I must obviously point out that this was self-reported by miners that were interviewed by the researcher. Coming to Zimbabwe, we had a student that did a project particularly focused on street hawkers. So these are people that work in the outdoors, and basically Zimbabwe's gone through some huge economic problems, and droughts have impacted severely on the economy, the rural economy, and a lot of people have flocked to the cities where they're struggling to find employment. So a lot of them are doing sort of informal jobs and working outdoors. And because the activities of these vendors are illegal, they don't have access to the formal city infrastructure. So again, they sort of fall between the gaps and have no protections. Their income levels are very low, and they don't have real access to water. They have to buy water, and so again, there's a high risk of dehydration. They also have exposure to air pollution and other issues. Moving on to their heat adaptation strategies. Basically, they try to avoid working in the sun. They construct shelters that are made of cardboard and canvas, wear loose-fitting clothing, but the barriers, I've touched on most of those. There's fierce competition for shady spots, and these people are poor and they also lack education. Furthermore, in Ghana, the subsistence farmers are also struggling with drought, and that's impacting on them. Their work is very manual, and they have to work in the sunshine, struggle to compete with for land, and also a lot of the housing, as you can see in this picture, is inadequate, and a lot of them actually now can't get enough grass because of the drought to re-roof their houses, and so they're using corrugated iron or sheets of metal, which obviously impacts them in terms of heat. They struggle to get water. They have to pull it out of the ground of these wells and then irrigate their crops by hand with buckets. So the situation is really dire and very similar to what it is in Zimbabwe. In Australia, we've had a few studies done with regards to heat stress. One of them was testing the drinking of ice slurry as an intervention to cool down in the heat. This was trialed in a laboratory and then tested on an oil rig, and it seems to work pretty well in terms of reducing core body temperature. Of course, there are issues with getting access to the ice slurry and drinking enough of it. In terms of the heat acclimatization trial, we had a look at FIFO workers and how heat stress sort of impacts on them when they come from a cold climate. to their FIFO environment. They take a few days to adapt to the environment and become acclimatized. And then, of course, when they go back home, they lose that acclimatization. So this was pretty much a pilot study, and we're keen to explore this a bit further in order to determine what can be done to increase the or come up with the ideal FIFO roster. We've also done some research to try and determine what heat factors might be inside a chemical suit. So that little instrument there, the Lascar monitor, we put those inside chemical suits and had a look at how humidity and temperature was sort of building up within the suit within a period of time. And that can be used to actually predict WBGT experience within the suit. So basically, we've also discovered that heat stress impacts on hearing. And if your core body temperature is elevated, then there's a temporary threshold shift, which is associated with that. And finally, we have a student currently looking at the water misting systems, which is used a lot in the northern parts of Australia to cool people down. But there is a real threat of pathogens growing in the plumbing. And of course, we have detected Legionella in those. This is an ongoing unpublished results at the moment. So in conclusion, informal sector workers in Africa have very limited access to protections. By contrast, those that work in the formal sector pretty much are aligned with the situation in Australia. There are vast differences in the heat adaptation potential and strategies that are adopted in developing and developed countries. In Africa, electricity or the lack thereof is a key factor, and solar power would go a long way towards providing the ability for people to cool down, particularly at night. Emerging research opportunities in Australia are centered around mitigating factors that could involve acclimatization of workers and coming up with the ideal FIFO roster. So if anybody has any interest in any more of this, these are published papers, as I said earlier on, and I can give you links to those. Thank you.
Thanks so much, Jacques. That was fantastic information. I love the way you're doing the comparison between different countries and also the developing and developed and developing countries. I think it's really important to make those comparisons and think about how we can help, particularly with the challenges of drought and other issues. So thank you very much. Just want to report online, we have around 500 people this afternoon, so thank you very much for your participation. Keep it up. And our next session is also about heat, and it is heat exposure and safety, which is presented by Blesson Varghese, who's a researcher at the University of Adelaide. So keep the chat going. See you after this session.
Hi, I'm Blesson Varghese and I'm presenting on heat and work injury. So the heat health risks to workers can be summarized in this diagram, where the type of work and work environment contributes to the heat stress problem that affects the workers. Heat strain is the response to heat stress, which consists of a physiological response whereby people start to sweat, or a psychobehavioral response whereby people start to feel discomfort or change behavior. The combination of these two responses increases the vulnerability for heat-related illnesses such as heat exhaustion and heat stroke. But the interaction of the workplace hazards could potentially cause injury. So here we have a construction site and there are about 8 workplace hazards that could potentially cause an injury on a hot day. So this national project was concerned about the impacts of ambient heat on occupational injury along with its prevention and management. The project consisted of 4 parts. In part 1, we looked at workers' compensation data. Part 2, the survey of stakeholders. Part 3, case studies with injured workers. And part 4 was the development of key recommendations. So there were multiple lines of both quantitative as well as qualitative evidence from this project. In part 1, we assessed the impact of temperature and heat waves on occupational injuries. In Adelaide, where we linked the workers' compensation claims data with the temperature data. We looked at the temperature on the day of the injury and compared it with temperatures on other days of the week when the injury had not occurred. We had just over 200,000 claims over a 10-year period, and the exposure ranged between 10 to 46 degrees with the mean of 23 degrees. And we found that the risk of occupational injuries increased with temperatures above 25 degrees, with a 30% increase at 40 degrees compared to a 25-degree day, affecting young workers, those in medium and heavy demanding jobs, those in electricity, gas, and water, and the transport and storage industry. Injuries affecting the upper limbs, the lower limbs, those involving the non-powered hand tools, power tools and appliances, those resulting in burns, fractures, and wounds and lacerations had increased both during moderate and extreme hot conditions. About 2.5% of injuries over a 10-year period could be attributable to heat, which converts to around 476 injuries per year, with most of the burden coming from moderately hot temperatures. This suggests a substantial underestimation of the heat and work injury problem, as only 0.1% of claims are documented as heat-related. So we use the Bureau of Meteorology's excess heat factor definition for heat waves that maps heat waves according to their severity. And we had used data from 4 capital cities with diverse climatic conditions. I want to point out, while the temperatures during those heat wave days are quite different across all 4 cities, they are comparable in terms of their severity. So a 40-degree heat wave day in Perth is comparable to a 34-degree heat wave day in Brisbane. So during heat waves, we found consistent increase in occupational injuries across all 4 capital cities despite the differences in climate, with the highest effect in Brisbane. Young workers, new workers, those in outdoor and some indoor sectors were the most affected. So to better understand how and why these injuries were occurring, we conducted 2 national online stakeholder surveys with health and safety professionals and safety representatives. We asked them about injury experiences in their workplace and workplaces that they inspect. So we had just over 500 participants between both the surveys, of which majority acknowledged that this is a problem contributing to manual handling, hand injuries, along with fatigue and severe dehydration, injuries from slips, trips, and falls, those from not wearing PPE, and fogged up safety glasses were also documented, affecting both the new as well as young workers. The lack of policy adherence and poor supervision, along with no access to shade and wearing of PPE, was documented as the contributing factors. And we found that injuries were quite high in workplaces where self-pacing or work rest regime was not frequently available for outdoor workers, whereas for indoor workers, if access to cooling water and self-pacing was not frequently available, then they had higher injury experience. While workplaces had a hot weather or heat stress policy, there was a lack of heat stress training. And the barriers included the lack of awareness and training, management's commitment, and attitudes to keep working at all cost. And some of the most important prevention measures suggested by the participants included the need for work to cease if temperature is extreme for outdoor workers, whereas the professionals thought the need for more heat stress training. Whereas for indoor workers, the reps thought the need for air conditioning, whereas the professionals thought the need for more heat stress training. So we also collected some data in terms of the qualitative data to better understand the heat and work injury issue. So we had a national survey of workers, a short survey, which was filled by just over 380 workers who documented wide different experiences of heat-related injuries, including dehydration and fatigue. And some of the recommendations included the need for more hydration, better designed PPE, and the need for management to be more understanding of the heat and work injury issue. So we also spoke to injured workers. This was about 21 people across 5 states and different industries who reported a range of heat-related symptoms and injuries. Most of them were minor, but some serious ones as well. And the contributing factors included factors such as dehydration, fatigue, and PPE. And the recommendations included the need for more awareness and training, along with good supervision, and the need for more hydration as well. And here is an example of a quote from an injured worker, that there needs to be an understanding from the boss's perspective that we're not machines, but we are humans, and humans do have limitation. So this highlights the significance of the issue. And finally, we were able to look at the telephone calls made to the Safety Regulators Help Center, and we searched for heat-related calls. So just over 100 calls were analyzed, of which majority or more than half were coming from indoor workplaces with minor to more serious health effects being documented. And some of the issues included workplaces where extra breaks were being denied, management were pushing people beyond capacity, or policies were not being. So here we have an example of the comments that the callers had made. The last one is quite like striking, where the foreman's attitude was that if he stops work, don't bother coming back the next day. So this highlights the size of the problem that we're talking about. So to recap, imagine this being a workplace with workers where heat exposure is a hazard that leads to heat-induced illness. But the interaction of physical hazards could contribute to a physical injury, resulting in a compensation claim being made. Within workplace, we have the safety representatives who can represent the safety issues and concerns of workers with the management. And outside the workplace, we have the health and safety professionals who perform a wide range of functions. So by speaking to these workers and these stakeholders through the surveys, the interviews, as well as the complaints data set, we are just able to answer these questions as well as understand how and why these injuries do occur in workplaces. So put together, these two lines of data contributes to a better understanding of the heat and work injury issue. So to conclude, occupational injuries do increase in hot conditions and during heat waves, and it's not just an outdoor industry problem. But the mechanisms are complex, and they depend on the worker and the workplace characteristic that need to be considered. As we are predicting increasing temperatures and more and severe heat waves, the issue of injury is with us for now to deal with. Thank you for your attention.
Thanks very much, Blesson. And thanks also for answering the chat. You had some interesting questions there, particularly with how you defined the heat maps and the heat that you actually studied. So thank you very much for that. The next presentation we have is a 5-year cross-sectional review of underground vehicle exhaust emissions for elemental carbon and for oxygen nitrogen oxides using de-identified data from 13 Western Australian underground mining sites. And it's presented by Graham Matson, who's an occupational hygiene consultant for AIOH Hygiene. Please remember to use the chat function and keep that chat going. It's really great this afternoon. Thanks very much. Over to you.
Hi everyone, thanks for joining my presentation today. I'm Graham Matson, and my presentation today will be a 5-year review of underground vehicle exhaust emissions of de-identified data from 13 Western Australian underground mine sites. This will be focusing on elemental carbon and nitrogen oxides. So during the presentation, we'll go through the background, the aim, some WA legislation, materials and methods for the sampling that we conducted, have a look at the results and outline some conclusions from the review. So just a background on the project. We've been conducting diesel emission exhaust testing since 2015 on some underground mine sites in Western Australia. Over the 5 years, our client base has grown, and it's led to a large database of information of diesel exhaust emissions results, a total of 13 sites. The aim of the study is to review diesel exhaust emission tests from 13 Western Australian underground mine sites to evaluate levels of elemental carbon and nitrogen oxides against benchmark criteria, and to recommend controls for potentially exposed underground miners. It's just some of the legislation in WA that the mining organisations go towards. It's the Safety and Inspection Act and the regulations. Found some of the guidance material very handy from Western Australia, the management of diesel emissions from 2013, and Queensland had some good guidance as well. If you're interested in reading, if this is a topic of interest, they were handy. So in the Mines and Safety Inspection Regulations in Western Australia, section 10.54, undiluted exhaust sampling, it states that each responsible person at an underground mine must ensure that undiluted exhaust gas produced under all standard conditions of engine speed or load by the engine of a diesel unit underground at the mine is sampled and analysed. So they're mandated to do the gas testing. A point here is that it's only based on the exhaust gas. It doesn't state anything around the diesel particulates, which I think is a bit of a gap, and we'll go through the results a bit later and hopefully clarify that a bit more. But a focus on diesel particulates from the exhaust is, I think, important. The testing needs to be conducted at no more of 250 engine hours or at intervals not exceeding 1 month, and after any maintenance work is done on the turbocharger or fuel injection system. So we'll go through the materials and methods for the sampling that we conducted. The study, I conducted a cross-sectional study, so we reviewed the diesel exhaust emission testing data that we collected during the 2015-2020 period from 13 Western Australian underground mines. And the tests that we conducted, the diesel exhaust emissions, they covered elemental carbon, which is the diesel particulates, carbon monoxide, carbon dioxide, and nitrogen oxides. This is some of the equipment that we used over the period for testing. The top two collect the elemental carbon results, which are the diesel particulates, and the bottom two are for the gases. So we did a fair bit of literature review before conducting this testing to find the testing criteria, which we broke down into 3 risk categories. So you've got your low risk, which is anything under 25 milligrams per cubic metre, which means the vehicle can remain in service. You've got the moderate risk. The vehicle can remain in service, but maintenance is required, and this is between 25 to 50 milligrams per cubic metre. And we've got high risk, the vehicle to be removed from service and repaired, and this is anything over 50 milligrams per cubic metre. For the gas, we've got the NOx, anything over 1,000 ppm is considered high risk and the vehicle is to be removed from service. And for carbon monoxide, we've got 1,500 ppm, and the same again, it's considered high risk and needs to be removed from service and repaired. So we move on to the results and discussion. So overall, we had a total of 5,597 vehicle emission tests conducted. 2,804 of these tests were from heavy vehicles, and 2,793 were from light vehicles. So it's about a 50-50 ratio there. For the elemental carbon, 4 sites out of the 13 recorded exceedances over the 50 milligram per cubic metre criteria, and nitrogen oxide, 7 of the 13 sites recorded exceedances. And interestingly, all the exceedances came from heavy vehicles. So we've broken down the elemental carbon results into 2 categories, the non-filtered vehicles versus the filtered. The filtered vehicles being the ones with the diesel particulate filters installed at the time of testing. So there's quite a small amount of total tests for the filtered vehicles compared to non-filtered. And you can see the exceedances all came from the non-filtered vehicles, with 10 results above 50 milligrams per cubic meter, compared to filtered vehicles had 0 results. You can also see in the filtered vehicles there's 8 results in between 25 to 50 milligrams per cubic meter. The only kind of answer to that is maybe they haven't had much maintenance done on the filters, or they haven't been cleaned properly. They're not using them to their maximum, which is causing results to be this high. This is just a scatter plot that we've done on the EC results per site. So you can see there's quite a few results there that are quite high. We've got 3 above 100, and the highest result coming at 148 milligrams per cubic meter, which is almost 3 times the testing criteria that we've considered as a high risk. And then you've got a couple of results there between 60 to 100. So it's just interesting to see on a scatter plot. We've got 2 graphs here that we've broken down into sites and into the risk categories. The first graph there is the exceedances. You can see 4 of the 13 sites have recorded an exceedance, with the number 12 there has 4.3% of their results were actually exceedances, which is quite high. The interesting fact from these 2 graphs is there was only 2 sites that didn't record any results in these 2 categories, and that's site 6 and site 9. And these are the 2 lower end results. So in the graph 4 there, we want to see, the goal is to have 100% of results in these, and you can see site 3 there only had 73.3 being the lowest, with the highest compliance there of 96%. So there's room for improvement to try get all results into that graph. The nitrogen oxide results, so we broke that into non-filtered versus filtered again, and there were 12 exceedances from the non-filtered vehicles and 0 from the filtered vehicles. And you can see in the graph there that there's 7 of the sites that recorded an exceedance. So throughout the sampling, there were a few limitations from the collection process. We found that equipment failure while on site prevented all contaminants to be tested for during each site visit, and the testing conditions were not always the most suitable. Underground mines can be very difficult and challenging places to test in, so it made for not all the data to be valid or credible. So we'll move on to the conclusion. There were 5,597 total tests conducted from 13 underground mine sites. Of these results, 10 exceeded the limit for elemental carbon and 12 exceeded the limit for nitrogen oxide. We come up with the following conclusions: that firstly, very few vehicles tested are fitted with DPFs. All exceedances were from vehicles not fitted with DPFs. The management of diesel exhaust emissions is most definitely reactive. There is no proactive implementation of DPFs. The lack of implementation of DPFs in fleets, given the exceedances, indicates legislative motivations are not sufficient to result in their installation. And further research should look at the maintenance and management of DPFs and catalytic converters to understand their long-term performance. I just want to say a big thank you to Elaine Lindars and Ken Asakwe for their assistance and getting me to do this presentation. It's greatly appreciated.
Fantastic. Thank you very much, Graham. What an interesting project, particularly running over 5 years with so many tests, 5,500 tests, just incredible. Thank you very much for that, and there'll be still further time for questions for Graham on the chat. Our next session, before I do that, perhaps I remind you this is the last kind of hour to check in with sponsors and the exhibitors on the page. So make sure you check in with them, find out the latest information, and also last chance to answer the trivia questions. Our next session is called Adding Maintenance of Engines to Your Control Toolkit by newly graduated Dr. Jen Hines, who's an occupational hygienist from EHS Solutions. So over to you, Jen.
Thank you for taking the time to tune in to me today. I'm Jen Hines and my topic is on adding maintenance of engines to your control toolkit. As occupational hygienists, a major component of our brief is to reduce exposure to workers. It's why we go to work. We're generally a fairly enthusiastic and passionate bunch of like-minded people doing our best to improve the workplace so workers are less exposed to hazards. So today I'm going to talk to you briefly about something that has kept me awake at night, and that is controlling diesel emissions. We all know that diesel exhaust is a carcinogen and we all know that it needs controlling. We all know that there's alternate powers coming and vehicles are becoming more available in these. But in reality, diesels are going to be here for long enough for us to do something about it, to help our workers. So once we've looked at these easier options, although sometimes they can be unattainable by some businesses, such as new higher tier engines, clean low emission fuels, dilution ventilation, local exhaust ventilation, good seals on cabs, the right and appropriate air conditioning filters and filters on for the exhausts, and driver education, just to cover a few, we're left wondering what else that we can do. And this is where maintenance comes in, maintenance of the engine and maintenance of the exhaust system. So over the next 9 minutes, I'm going to take you on part of my 4-year journey I've just completed, where I was fortunate to spend significant time in a coal mine, messing around with vehicles, testing their emissions, maintaining and fixing engines and exhaust components. That bit wasn't actually me though. And monitoring to see if the changes in the vehicle emissions had any impact on workers' exposures, and then attempting to correlate these changes in fuel consumption with this maintenance. I have also incorporated a few other tips and tricks and information from other industries that I've worked in to control diesel exposure. And I'm going to provide you with some of this information that I've learned along the way to make this a workable control in your workplace. I think that hygienists do tend to steer away from maintenance as part of a control, as it's not something that we typically understand, unless fixing engines is part of your hobby on the weekends, and then you're definitely going to be a step in front. Diesel emissions are found anywhere that diesel is used, diesel fuel is used, and becomes more problematic where there's restricted ventilation. Examples of situations and of vehicles where increased exposure to diesel emissions occur are from diesel-operated mining equipment, diesel maintenance workshops, from ships and forklifts or loaders in the holds of ships, underground or enclosed car parks, storage sheds where materials are handled by diesel loaders, diesel generators or compressors, airport tugs, light towers, and scissor lifts as well. I'm sure that if you think of your own workplace or places that you've visited, you can really quickly add more to this list without very much effort whatsoever. So now let's get on to diesel emissions-based maintenance. Legislation requires that we control to as low as reasonably practical, and EBM is considered reasonably practical and thus requires further exploration within our workplaces. EBM forms part of emissions-based maintenance, but goes further. Essentially, you continue to do what the logbook requires, plus check the individual engine exhaust to see if more maintenance is required. As we know, controlling emissions from a source is the best place to reduce contamination. Therefore, if we undertake exhaust emission testing, conduct specific maintenance as a result of analysing the emissions, we should see a reduction in exposure, which will lead to protection in worker health, improved productivity in the form of reduced fuel consumption, less breakdowns, more reliable vehicles, as well as reduced operating costs. And importantly, for these exact same reasons, we see improved productivity. But even if we introduce a new clean high-tier engine, it was only ever going to be good as the maintenance it receives. If it's not maintained, it will deteriorate and will expose workers to high levels of diesel exhaust. So include these in your program. Ideally, we're going to be testing for carbon monoxide, carbon dioxide, oxygen, nitrogen oxide, nitric oxide, and diesel particulate matter as elemental carbon. These should be conducted before and after exhaust controls, so it can be determined if there are any issues developing on the manifold, such as timing, or within the exhaust controls like filters and catalytic converters. It is possible for controls such as catalytic converters to increase rather than to decrease exposure if they're not working properly. Once an EVM program is set up and preliminary testing has been completed, it can immediately be recognised if the engine and exhaust controls are performing with an acceptable range for the type of engine with any new results determined. If the engine is within the acceptable range, it's appropriate to put it back out into service. If not, send it for maintenance, retest, and then put it back into service. Testing should be done on a regular schedule. If engines have some sort of servicing done each week, such as they do in mining operations, then testing on a monthly basis is appropriate. If maintenance is longer than this, then the period of testing can be longer. The engine should be continually maintained to meet target values that you set for that specific type of engine on that specific site. Please remember, if you're not doing testing, you don't know. You can't see, you can't smell if NO2 is excessively high due to an engine going into smoke control mode. So we have to be testing. Now, some of you will be sitting here and saying in some instances that we can't do testing on a manifold, and that's right. So things like light towers and generators, there's only one place to test the exhaust, and that's right on the exhaust. If there's no other controls in place between the motor and the exhaust system, then the exhaust outlet may be the only location to test. This shouldn't stop you from implementing this control. You can still do mini version of emissions-based maintenance and just test at the tailpipe. There are far more advantages to this than disadvantages though, although don't let it replace full EBM testing where that can be done. Just testing at the tailpipe is obviously a quicker process. You can still profile the engine and determine if it's okay to be put into operation, and it also allows you to remove a vehicle or engine in a timely manner and have it maintained. Visiting the vehicles that we looked at earlier, these are some examples of the locations that you'd be likely to test. So on the manifold and the tailpipe of these first two here, on the larger engines and things like loaders, and then just on the tailpipe or the exhaust outlet for generators, for light towers, for civil lifts and for tugs, those type of things. Now, it does take a trolley load of equipment to analyse the exhaust. Although it's all portable and can be carried, you do feel someone like a juggling pack horse when you're carrying it all. However, the process to test the exhaust is quite quick, with each test only taking a couple of minutes. Once the equipment has been tested, it's at operating temperature. This is the equipment that I used. I haven't got any shares in any of these companies, so you might use some other equipment. But I used an Ecom gas analyzer, and EN3 is the one that's available now. I used a diesel checkmate for the particulates, and this has been calibrated to NIOSH 5040, which is really important. I used a water trap because some of my vehicles have got very wet exhaust because they've got scrubber tanks. A mixing unit is vitally important for any testing, and because this is where you take a uniform mixed sample from. And then I had a computer that has the program actually on it, as well as a back pressure gauge and filters there for consumables. The beauty of using the software is that you can use your own data to quickly process this visual information, such as the graph that's on the screen there at the moment. This colourful graph is showing the same engine over time. The red colour is carbon monoxide, so have a look at that one. This is the most interesting trend in this graph. Note again that this is the same engine over time. You can see at the start, CO levels are quite low at approximately 160 parts per million. By the final results, it's up around 570 parts per million. The question should be being asked is, why is this happening? What's causing the CO to rise? However, the really interesting point is that although there's something obviously starting to fail, this wouldn't be picked up unless it's being measured. And even if it was being tested under statutory conditions, it still wouldn't be required to be tagged out because the statutory limit is actually about or nearly double this. So meanwhile, exposure to CO continues and the vehicle continues to deteriorate. It might have been that the catalytic converter needed cleaning or a restriction was developing in this case. A similar graph but different. So this is different engines but of the same type and the same age. The question that you'd be asked here is, what's happening with vehicle number 83? It's way higher CO than the others. Obviously, it needs to be fixed. And then you'd have a look at these lower ones here, 13, 14, and perhaps 12. This vehicle had a blockage in it that needed fixing. Now we need to help us with the evidence to prove that this is a worthwhile investment. We're good at personal sampling. Who doesn't love to go to a workplace and collect some samples? However, you're going to have to find something else to help prove your case to implement EBM, not just personal exposure reduction. Reduced exposure to diesel engine exhaust is going to be enough for us as occupational hygienists to implement, but it's not going to cut it for many businesses considering implementing this control. You're usually going to need to link it with something else, such as reduced fuel consumption, perhaps reduced diesel filter changes, improved vehicle reliability, or a few. I linked mine with decreased fuel consumption. There are lots of things that need to be done along the way when collating EBM samples, including ensuring the sample method is reliable and repeatable. Preferably complete pre and post control technology sampling to determine both engine and control technology faults. And you've got to be loading a hot engine, critical for both gases and particulate testing. So a hot engine is at operating temperature. So the question has to be, does EBM work and is it worth implementing? Yes and yes, absolutely. What it should do and has been shown to do is to reduce emissions at the source and reduce worker exposure to diesel particulate matter. It's also valid to expect and receive a productivity gain by using less fuel. The size of the exposure reduction and productivity gain, however, is going to depend on the condition of your fleet to start with. So I would encourage you to add emissions-based maintenance to your toolkit to control exposure to diesel engine exhaust. It's not going to be a walk in the park. It does take some doing, but it's readily achievable. Take on the challenge and investigate it in your workplace. Thank you very much for taking the time, particularly if you've managed to hang on to the second last presentation of the symposium to listen to me today. If you would like some more information, then please feel free to download my thesis. The full information is contained within it. Thanks very much.
Thanks so much, Dr. Jen. Very good information. I love your practical tips and information that you provided today. And also the motto, you know, a clean engine is only good as the maintenance it receives. So thank you very much for that. Our next presentation is from Holly Fletcher, who's the Senior Occupational Hygiene Manager at Transport for New South Wales. And her presentation is on the health of Chilean mine workers. Is it bad and how could it improve? Thanks, Holly.
Hi, my name's Holly Fletcher. I'm a Senior Manager for Transport New South Wales, and today I'm going to be presenting some research that I've been performing in Chile. So the overview of my presentation is to provide you with some context of the scope of the research, communicate the methodologies that we applied to collect our data, communicate the results, so the themes that we identified and the conclusions that were made, and also communicate some of the recommendations that we've made for further opportunities in the context of this research. So historically, mining was a really industrialized and really manual occupation, and over time and with improved technology, there's been a transition from manual physical work to a more sedentary type role performance, and there's now a recognition of new occupational diseases, and that's been resultant of people occupying more sedentary roles, and where people historically worked, that those environments are being redesigned, and we're seeing people in the mining industry in particular who are overweight or obese or suffering comorbid illnesses such as diabetes or other comorbidities like cardiovascular disease. So our research and in context of mining is in Chile. The people that work in mines in Chile are no different really to Australia. They're often in remote locations, and the access to food is typically provided by the mining companies, and this has often led to overconsumption of food and increased body weight. In response to this, in 2013 in Chile, the government introduced some legislation, and it was medical surveillance criteria that people who worked at altitude, so above 3,000 meters, it was criteria that you need to satisfy to either gain entry to work in the mining environment or to maintain their position and occupy their role in the mining environment. So we developed a research partnership, the University of Wollongong, with the Mutual de Sinigrad, and we conducted the research in partnership with them in Chile. So the definition or the relevance of this problem is that the medical evaluation criteria is applied to persons who either it gets applied for pre-selection and then it gets applied for continued employment. So the pre-employment criteria in 2015 meant that 15% of applicants who were applying for a role actually failed and didn't satisfy that pre-employment criteria. And in 2016, that percentage increased from 15 to 16%, and applicants failed. And of those applicants that failed, 62% failed because of cardiovascular or metabolic abnormalities. Annual medical surveillance, so these are people who are employed in the industry and have to satisfy or participate in an annual medical examination and satisfy the criteria there. In 2015, 8.4% of employees experienced temporary restrictions, so they had to participate in an improvement program to improve their health. And 1.2% were permanently restricted from continuing occupation in their role. In 2016, those percentages increased, so 11.3% were temporarily restricted and 1.9% were permanently restricted from continued employment. And the observed increase was really resultant of cardiovascular abnormalities and metabolic abnormalities. And we ask, why is this relevant? What's the significance of it? And the significance is that it limits the selection of people who are suitable to be recruited and placed to service the mining industry. And for those who are already servicing the mining industry, it increases the requirement for managing those people with a reduced fitness for work. It increases risk and it also reduces productivity. So our research aimed to understand, first of all, the health of the study population, and we aim to contextualise those social, environment and cultural variables that influence those health outcomes. Our research was conducted at a state mined operation, Codelco, and it was at their Andina division, and they employ 1,705 people, and 91% of those are occupationally exposed to altitude. We recruited 242 participants. 40 of those participants also conducted or participated in face-to-face interviews. They were recruited between September and February in the last year. Our methodology was a mixed methods approach. We conducted semi-structured face-to-face interviews to collect some qualitative data, and our quantitative data included obtaining de-identified medical surveillance data of 1,622 persons, and that included parameters of overweight and obesity, blood sugar, blood glucose, and cholesterol. And we also conducted a questionnaire, which was a modified version of the all-employee survey, which is a validated instrument. It was translated and adapted for application in Chile, and 242 persons completed that. So I'm going to communicate the themes of the results of our research. So I'm going to communicate the health outcomes of our study population, their perceived health status, and a value that they place on health and a desire to be healthy. So the research population is presented here in red. The Chilean population is presented here in blue. And this is the distribution of body mass index across these four categories, essentially. So the results of the research demonstrated that a significant proportion of the research population was overweight or obese. That totaled 80.6%, and is technically consistent with the prevalence of of overweight and obesity in the general adult population in Chile. And the trending is pretty much the same. However, in the overweight and obese categories, they're marginally lower when compared to the general population. However, they're not statistically significant. Comparison of non-communicable disease risk factors demonstrated that the research population had a reduced prevalence of elevated blood pressure. They had a reduced prevalence of elevated fasting blood glucose and total cholesterol. I'll just go back to this slide. And they also had a lower mean systolic blood pressure. And even though these results are lower than the general Chilean adult population, they're not considered to be, they're only considered to be marginally better. They weren't statistically significant. The results of the perceived health status is very interesting. Oh, pardon me. 92% of the research participants expressed and communicated that their health was good or better. And however, the perceived health versus the actual health was quite contradictory. So the overweight and obesity prevalence is commensurate with the Chilean adult population. Their non-communicable disease risk factors were slightly lower. However, there was a genuine belief that they were healthy. So despite a significant proportion of being overweight or obese, they end reporting inadequate physical activity and dietary nutrition. They believed they were healthy. And this disparity was an interesting observation, and I think it warrants further investigation to explain why such exists. And it may be that they're self-rating their health because they're comparing themselves to the general Chilean adult population, of which the general population, 73% rate their health as good. Or it could be further, I guess, embedded in this deep-rooted relationship that has been documented, and that's the relationship between social determinants in health. And that's those people with high incomes who self-rate their health as better than those when compared to lower incomes. It should be noted that both these theories weren't identified during the research. However, they've been presented now just to highlight the social and cultural factors that have the potential to influence health status. Interview participants placed a significant value on health and a desire to be healthy, and they cited this as a personal motivator to either continue participation in work or to maintain a connection with their family. The value was placed on that inherent enabler for work. However, it afforded them a great benefit to their families, and it allowed for them to prepare for future uncertainty. And this is interesting in the context of the social unrest we're observing in Chile. So the work-related factors identified were identified to impact both health and family connection. So health promotion was applied at the research site. There's a genuine commitment to improving health, and there's a number of health interventions that have been implemented. However, the research population indicated that there's a greater focus on work-related safety than there is on physical and psychological well-being. They communicated, and we identified that it's not prioritised the same, and those interventions within a safety context often eclipse health programs that have been implemented. So it's often not the design, what we identified was either the design or the implementation of those interventions that constrained participation, not the willingness to participate. And two factors that influenced that were either long commute durations, which equated to 4 hours a day, or not an absence of employee desire. Opportunities. The main opportunities really is to maintain the collection of de-identified medical surveillance data, purposely for trending it, and to continue that analysis and that trend of that population over time. There's great opportunities to establish interventions that can be tailored to align with existing systems, and they should be designed and co-implemented with the workers. There's significant opportunity for future research to investigate that variation observed in population health, in the research population's health versus the working population health, so comparison between industries, and also investigate that potential relationship between occupational fitness requirements and non-communicable disease progression over time. Thank you.
Thank you very much, Holly. That was fantastic. I appreciate the challenges you must have had in this process, and also considering the peripheral, I think, that we sometimes forget about as occupational hygienists when we're considering chemical, physical and biological hazards. And these other challenges impact workers' health. So thank you very much for your presentation. The next session we have this afternoon is unfortunately our last, and it is from Professor Robin Burgess Limerick, who's a professor at the University of Queensland. And his session is on continuous monitoring of whole body vibration associated with surface mining equipment. Unfortunately, he's not available online this afternoon. He had another thing that he couldn't make it today. So keep the chat up, and maybe there's some other people who are online who can perhaps answer queries which can come up from Robin's presentation. I'll leave it to Robin now, and see you soon.
G'day, thanks for joining me here. Today I'm going to talk about the measurement of whole body vibration. So one of the first thing to recognise is that long-term exposure to whole body vibration is strongly associated with adverse health consequences, and particularly back pain. The likely mechanism of injury is microdamage to the vertebral end plates caused by the vibration exposure. The body responds by repairing the end plates, and they get thicker as a consequence. However, the intervertebral discs that lie between the end plates do not have a blood supply of their own. They only receive nutrition by fluid movement through the end plates. So if the end plates are thickened by the response to the loading, then that leads to reduced nutrition of the discs, which in turn compromises the ability of the discs to respond to their normal loading and remain healthy. The vertebral end plates appear to be most sensitive to accelerations within the range of 2 to 10 Hz. Unfortunately, the vibrations to which we're exposed when we're sitting in moving vehicles includes acceleration within those frequencies. There are methods for the evaluation of whole body vibration described in AS 2670.1. This is a mirror of the ISO standard 2631.1. The accelerations experienced by a seated body are measured in 3 orthogonal axes, with the Z direction perpendicular to the plane of the seat pan. Frequency weightings for the evaluation of health effects are applied before the amplitude of the accelerations are calculated. There are 2 primary ways of quantifying whole body vibration amplitude. The RMS, or the standard deviation of the acceleration time series, is perhaps the most well known, but there's also a vibration dose value, or VDV. The vibration dose value is a 4th root measure that's more sensitive to high amplitude peaks. There are some researchers who believe that this better represents the response of the body. The magnitude of the vibration dose value increases with measurement duration, and so it has to be normalised to a duration, typically an 8-hour duration, so we would say VDV8. The standard provides an informative annex that specifies a health guidance caution zone, illustrated here for RMS, with corresponding values for an 8-hour daily exposure for vibration dose value. The annex suggests that for exposures below the zone, health effects have not been documented, while exposures within the health guidance caution zone indicate that caution is indicated, and that health risks are likely where exposures exceed the zone. It's not great, but it's the best we have, and it's typically understood as indicating that whole body vibration amplitudes of low, medium and high risk correspond to below, within and above the health guidance caution zone. So that's how you would go about measuring. The devices that are used, the gold standard ones at least, are pretty expensive. They're pretty unfriendly user interfaces, and they're relatively fragile. We found that the routine use of such equipment on mine sites was problematic, to say the least. Even for short-term research projects, the cost of obtaining sufficient data for meaningful results was prohibitive. So one avenue we explored was the development and validation of an iOS application that can be installed on iPod Touch devices. The WBV app has many advantages over gold standard devices. The major limitation it has is a 100 Hz sampling rate that's imposed by the operating system. However, we found that was adequate for the frequencies of interest for measuring whole body vibration. The application is simple and powerful. It allows the inspection of raw data so you can check the data quality. It provides the RMS and VDV values for the measurements in comparison with the health guidance caution zone, and it also allows inspection of the frequency spectrum for any sample. The raw and frequency weighted data can also be downloaded for more detailed analysis. We conducted several validation studies, and the app was found to compare well to simultaneous measurements obtained from gold standard devices. The application is available for free on the App Store. Go try it out. The finding that the data from the app are valid has been replicated by researchers in Canada and also at the US National Institute for Occupational Safety and Health. We've used the application for several projects in surface and underground mines with some success. However, it's still data collection in batch mode. It still requires someone to set up the device for each measurement, place it on the seat, or at least give it to an operator, retrieve it at the end of the measurement, and then download the data for subsequent analysis. It can be still a bit time consuming. A health and safety manager at a mining company we were working with wanted to go a step further, to embed accelerometers within the seats of surface mining equipment and relay the data through the mine's network to a server for continuous assessments. Our first attempt at this involved repurposing old iPhones and embedding them in truck seats. This worked, and you can see some of the data we collected. We could also collect GPS from the phones and so match up the location of different values. However, the problem we found was that the seat acted as an effective thermal insulator and the devices periodically overheated and shut down. Problem. Plan B was to embed an accelerometer only within the seat and to use a Raspberry Pi microcomputer to store and forward the data to the server. This also meant that we could connect a second accelerometer on the floor under the seat to allow comparisons between the two. The data you can see here is an example of floor and seat accelerometer data obtained from a truck in operation at a surface coal mine. Comparing the frequency-weighted seat and floor measurements allows an assessment of the effectiveness of the seat in attenuating the vibrations received at the seat. That's called the SEAT ratio. Neat, hey? Plotting the accelerations as a function of GPS also provides the potential to identify roadway quality issues. If you collect the data from many shifts, that allows a better understanding of the variability of measurements obtained. So these are 181 shiftly measurements from a single truck over a 5-month period. It directs attention to a small number of measurements in which the VDV8 SEAT ratio indicates the seat is actually amplifying high amplitude jolts rather than attenuating the accelerations. Now, that's not what we're after. Seats, we want to remove the accelerations. So let's look into that a little more deeply. This is a 2-hour sample which illustrates an example where this has occurred. So you'll see, if you look closely, that a VDV8 seat ratio of 1.26. Anything over 1 indicates amplification, and 1.26 is really not good. So what's happening here is that there are high amplitude jolts that are being applied to the floor of the truck, and they're being amplified by the seat before they get to the driver. So, what's going on here? Well, the next slide shows accelerometer data from the same truck, driving the same circuit at the same speed on the same day, but starting about 2 hours later. So, let's have a look here. Well, the seat ratio is much better. For the VDV8, it's only 0.67, so a large amount of the vibration exposure has been attenuated. What changed? It's the same truck, same site, same speed. Well, the break in between was a shift change, So this is a different driver. We don't have the information to be sure, but my hypothesis is that the driver in the previous shift was light and either did not or could not adjust the seat suspension to suit their maps. So obtaining such continuous whole body vibration data allows the potential for sites to monitor whole body vibration exposures, identify the potential sources of high exposures, and evaluate the effectiveness of control measures. The project's ongoing with funding from ACUP. By the end of this year, we hope to have the fleet of 30 trucks and 15 dozers, plus excavators, shovels, graders and water carts in use at the mine, all instrumented and streaming continuous floor and seat accelerometer data. The next step is to automate the analysis so that the data can be effectively used by the mine site to manage whole body vibration exposures. The data will also provide a good baseline for the evaluation of proposed control measures such as innovations in seat suspension design or modification to roadway maintenance schedules. Thanks for listening.
Thank you so much, Robin. Really interesting information there. And remember, if you want to contact Robin, he couldn't make it today, his contact details are in the chat for you to catch up with him if you have any questions about his presentation. Well, it's time to start the wrap up, and today we have some winners. First up, I'd like to thank Alan Williams for the sheer volume of chat comments that he put in today and throughout the whole symposium, so thank you very much. And the winners for today with regard to their comments is from Peter Knott, and for the most valuable input and contribution today through the chat channel. Thank you very much. And also the second winner is Kerry Chung for his comment regarding the medicinal cannabis talk from Maggie Davidson, with his comment that he thought it was a joint presentation. Thanks very much, guys. And the last thing we want to do is wrap up with the quiz winners, the quiz answers perhaps, maybe. And that is, we've got some answers coming online now for you with the trivia quiz. You'll be able to see the answers to day one's trivia quiz. You've got the answers there. Who was the first president of AIOH? It was Trevor Jones. You've got the Hexlet there with the airborne dust measurement device of old. Imagine that as a personal sampler. Can't really even carry it really on my shoulder. We've got the AIOH members who've been AIOH presidents, and there were 4 of them. They're all listed there. When was the first sponsor? Was AirMet the first sponsor for the Development Award? 2001. And you've got the information there on what the old logo used to look like and what it represented for AIOH. For day 2, we've got the next quiz answers coming up. You can see them there. The first conference was held in 1982 at the University of Melbourne, quite a milestone if you think about it at that time. As a time when we really didn't even have a lot of exposure standards. So it was great that the scientific officers started to get together and the government officers started to get together. You've got that interesting device there called an Owens dust jet gun. And there's lots of similarities and commonalities with the 3 gentlemen represented there, and you'll see a few of them, a few of the comments there for the commonalities between those gentlemen. And they're all very well respected hygienists from AIOH. The winner of the 3M Best Conference paper for 2019 was, of course, Kate Cole and Michael Fisher. And what was the name of the theme rather of the Perth Conference in 1990 was Standards in the 90s, Real or Imaginary. The third day of trivia quiz answers are coming up now, and we've got that Dr. Ross Coletto was the inaugural Young Hygienist Award in 1993. You've got that incredible, not personal device of the cotton dust elutriator pictured there. We had some really great comments on that. Thank you very much. Trevor Jones is measuring airborne dust there, and he's actually holding up an X-ray film from the device that was used to actually measure dust in those days. Quite interesting, really. How many members have received Australian Honours Awards? And there's quite a few of them listed there, and congratulations for their contribution to the field of occupational hygiene over those years. Thank you very much, and your contribution is well recognised. And of course, the exposure standard for silica in the 1980s was 0.2 milligrams per cubic metre. And the last day, today's trivia answers are coming up now for you. We've got that there was the National Institute for Occupational Health and Safety. There was in the 1980s. The device here is a type of pitot gauge. I can hardly read the screen myself on my own screen. Yeah, we've got some clowns here. Yeah, I'm one of them. And so is John Henderson at the conference events. And also we've got the Tyndall effect being shown there. And one fantastic comment was that the beam was to beam me up, Scotty. So thank you very much for all of those. The last thing I want to do is to do a quick couple of thank yous to the exhibitors. Thank you for your support and exhibiting through this online forum. I hope it's been successful for you. It's been great to have you as part of the symposium. Also the sponsors at every level that we've had for this incredible event that we've run for the very first time on this platform for AIOH. Thank you very much. Also the presenters, we've had some fantastic domestic and international presenters for your contribution to our symposium. Thank you very much for your input and the fantastic information that you've shared with us via this platform. And also the attendees, your contribution and engagement throughout the whole symposium has been fantastic. Thank you very, very much. And it wouldn't happen without our support team. BACS AV have been fantastic in making the platform for us, doing the recordings and managing it today and for the last 3 days. Thank you so much to the BACS AV team, and also for our very own Samira at the office, our conference and events manager. It also wouldn't happen without her amazing contribution and support and the amount of work that's been done behind the scenes. Thank you very much. And the last group, of course, is the AIOH Scientific Committee, who's put together the program for this with our fantastic chair, Kelly Johnson. And I'm going to hand over to her now for the final words. Bye for now.
Well, I think there's two things that I'm very proud about. One is developing the occupational hygiene practice course at the University of Wollongong and seeing a lot of people go through that course. The second thing is going back to the 1980s, 1990s and bringing and further developing disposable diesel exhaust filters for the underground coal mining industry. This single thing, which is still in use today, reduced worker exposures by over 80%.
Achievements was that I helped to ensure that all the asbestos fibre counting laboratories in Victoria were doing consistent and reliable work. Proud that I edited and published Pam De Silva's unfinished PhD thesis as a book, which was called Science at Work. It hasn't had a wide readership, but it serves as a record of the development of occupational health in Victoria, and it was a fitting memorial to Pam, who was a very fine scientist. We won't see her like again.
A career highlight for me was actually to produce a series of newspaper supplements that we ran in the West Australian over here in WA over a number of years. The first of these actually came out when the 2008 annual conference was being held in Perth, and so we took the opportunity there to talk to the people down at the West Australian newspaper, and the intention was to promote the conference. The theme at that time was forensics at work, and importantly we wanted to try to bring the occupational hygiene message to the general public. Now this led to a series of supplements in subsequent years. These were called Noise Management in the 21st Century, and they were designed to support Hearing Awareness Week. Some of the supplements were as big as 20 pages, so they were quite useful contribution at that time. The purpose, apart from promoting Hearing Awareness Week, was also to promote the Institute and also the profession. And with these activities, we actually got out to about 650,000 people, the readership of 650,000, plus there was online readership as well.
Increasing the focus on the need to protect tunnel workers from silicosis is something I'm really proud of. Working to get occupational hygiene expertise to Victorian healthcare workers on the front line of the COVID pandemic would be a close second, but my greatest contribution to our profession is yet to come.
Congratulations AIOH on 40 fantastic years, and thanks to all the volunteers who've helped to get us to where we are today. Congratulations and happy anniversary.
Hi all, Pete Aspinall here, wishing big congratulations to the AIOH for 40 years. That's a big effort. 2020 has been an interesting year for a lot of us. Hopefully you're all well. Hopefully we can catch up in person, preferably at the bar at the 2021 conference. Cheers all.
Here's a question. Who has the best health and safety events? The Australian Institute of Occupational Hygienists, of course. Congratulations AIOH on your 40th anniversary.
I want to give a shout out to the AIOH and congratulate them on their 40th anniversary, and I look forward to the next 40 years with the Institute.
Thank you for attending the AIOH 2020 Virtual Symposium. What a fantastic 4 days we've had, filled with engaging content from our invited presenters who have joined us from both overseas and locally, and to all our other 40 plus speakers who together have updated us on new technology, new ways of collecting and evaluating occupational hygiene data, and the vital role hygienists can play in assisting with the current global pandemic. I would like to take this opportunity to acknowledge and thank the sponsors and exhibitors for making this event possible. A thank you to our gold sponsors, GCG Health, Safety and Hygiene, Safety Equipment Australia, AirMet Scientific, Draeger Australia, Active Environmental Solutions, 3M Australia, Rio Tinto, Red OHS MS Group, and Industrial Scientific. Thank you to our silver sponsors, CAC Gas and Instrumentation, On-Site Safety Australia, Edith Cowan University, Thermo Fisher Scientific, ADE Consulting Group, and Mount Isa Mines. Thank you to our bronze sponsors, WSP Australia, Gastech, Douglas Partners Proprietary Limited, NanoZen Industries, Atom Safety, and Lupin Systems. I hope over the 4 days of the symposium that you took the opportunity to network with your colleagues, our sponsors and exhibitors, and to download their handouts and freebies. Over the 4 days, we have showcased some memorable moments of the Institute and celebrated 40 years of the AIOH. Again, I would like to wish the AIOH a very happy 40th anniversary. We are grateful for the continued patronage of our members, and thank you for your ongoing support and involvement in the activities of the Institute. It is our members at all levels that make the Institute such a fantastic organisation to be part of. One thing this year has taught us all is to be resilient. We are stronger than we think, and together we can achieve great things. 8 months ago, we couldn't imagine staging a virtual event of this scale, but now that we have, there is no looking back. In 2021 and beyond, we will continue to deliver high-level professional development opportunities such as this. A huge thank you goes to the organising committee for pulling this unique online event together. Thank you very much to Dino, Linda, Peter, Daniel, and of course Samira. Thank you for all your hard work. I will miss our regular team meetings. We had such fun organising this event. We hope you enjoyed attending the symposium and are going away with new networks, new ideas and solutions for a better tomorrow. Thank you again for your support, and we look forward to seeing you all next year. Happy 40th anniversary AIOH.